Reciprocals to the rescue. All right, we already did a little bit of this earlier, but we're going to really get into it this time. This is lesson 2, chapter 3 still, or problem type, or chapter 2, lesson 3, and it is the fourth problem type in the book. 3/5 n equals 6. There are a couple of different ways, but I'm going to show you this way because I think it's the easiest and it has the least amount of steps. If you simply multiply this guy up here, this fraction, by the reciprocal, it makes this go away, and that leaves you with an n, and then you can multiply that same reciprocal on this side, and that makes it the easiest. So what's that look like? I take the times. My reciprocal of 3/5 is actually 5/3. I'm just going to flip it upside down. Now let me prove to you that this works. Remember that what is 5 times 3? It's 15. What is 3 times 5? It is also 15. Anytime you multiply a fraction by its reciprocal, it makes it so that the top number is the same as the bottom number, and when it's anything divided by itself is always 1. So that means all this amounts to 1n, and 1n is just n by itself. So I don't even need that 1. So then I'm pretty well done, but except for this one issue, if I multiplied by the reciprocal on this side, I must multiply by the reciprocal on this side. And I'm going to write it a little bit lower so my numerator is in line with this guy here. And I'm going to put the 3 underneath. And then, of course, whenever I am taking a whole number and turning it into a fraction, I just plop a 1 underneath. And it always works out. So 6 times 5 equals 30. And 1 times 3 equals 3. 30 divided by 3 is 10. So I know that n equals 10. All right, let's try another one. I'm not going to do as much work over here on the next one. 1 over 2x equals 20. The reciprocal of 1/2, or 1 over 2, is 2 over 1. 2 times 1 equals 2. 1 times 2 equals 2. 2 divided by 2 equals 1. And 1x equals just x alone. Done. If I multiply by 2 over 1 on this side, I should do that to this side too. 2 over 1. 20 times 2 equals 40. And that brings me to the end, y'all. 40, x equals 40. All right, now I've got 2 fractions. Here's the best way to do these kinds. First of all, if I was going to come up with a common denominator, the common denominator for 4 and 3 would be 12, because they have 12 is divisible by both 4 and 3. The easiest way to come up with a denominator is to just multiply the two numbers. 4 times 3 equals 12. Sometimes that gets you a number that's a little bigger than you need, and it just means on the back end you'll have to do a lot of dividing, but it does work. Let's go ahead and start with that. So this guy, the common denominator here is 12, so I'm going to take the whole thing and I'm going to multiply by 12. This equals 12 times 3 equals 36. X. My my pen here again, makes it 9x. Now let's do 12 times the other fraction. 12x, 12 times 1x equals 12x, correct? Then I would just plop the 3 still underneath there. 12 divided by 3, though, is 4x. Bringing down that minus sign. Now, I will have to, in order to do this, one other thing that I forgot to mention is that if I'm going to multiply this side times 12, I must multiply this side times 12. Because what I do to one side, I must do to the other side. So down here, what does that mean? 12 times 10 is 120. So what happens is 9x minus 4x, well, then I've just got like terms. I can go ahead and combine them. 9x minus 4x equals 5x. And I can go ahead and divide my 5x here to get rid of my 5. And then I will just go ahead and divide my 5. And this means, I'm going to write it over here, x equals, is that 60? 120 divided by 5 equals 24. Silly me, 24. Ta-da! All right. That is the end of that.